In previous videos we focused only on the static torque versus speed and the torque transients. Now what about the direction of the torque? When a motor drives the machine, power flows from the source to the motor, which is then converted into mechanical power for the load. General purpose unidirectional applications such as centrifugal pumps, fans, compressors and extruders require only one or two quadrant operation, and the power flow is always unidirectional, that is from the grid to the motor to the machine. Examples of this drive topology are the 3-level neutral point clamped and the modular multi-level topology. The front end of these drives can be considered as a one-way rectifier, often referred to as direct front end. When braking the machine, the power flows in the reverse direction, that is from the load to the motor. If the power flow reverses intermittently, an electronic braking unit can dissipate that energy into a braking resistor, enforcing a deceleration ramp to a high inertia machine is a typical use case. Occasional braking energy recovery is in most cases not economically viable. Now, voltage source inverters driving applications that impose significant and consistent power flow from the machine to the motor will need to be equipped with an active front end, allowing energy recovery to the grid. Now, how do the different topologies enable this 4-quadrant operation? Well, the former mentioned topologies, the 3-level neutral point clamp and the modular multi-level converter, are then equipped with an active front end, which is basically a repeat of the inverter. The active control of the input stage provides for 4-quadrant operation. Large inclined conveyor belt machines and test stands with the power drive system simulating the load of the tested machine are typical examples of this use case. Feeding the power back to the grid is often called 4-quadrant operation, or simply referred to as full quadrant operation. The cycloconverter, the PWM-CSI and the load commutated inverter or LCI are inherent 4-quadrant drive topologies. So no need to add extras there. The 2-level series cascaded multi-level H-bridge cells drive does not provide for 4-quadrant operation. An active front-end version of this architecture is rarely economically viable. So the direction of the flow, the power flow, is clearly an important parameter, but it is not the only one that determines the configuration or topology of your drive. Another important one is the power quality, both on the drive's input and output. You can view those videos on our channel or visit pro-ethic.com for more practical vendor-neutral advice.